Testing is what can make or break your development career. There are a lot of successful developers who can create applications without ever writing a single test. Unfortunately, not being able to write tests can stagnate your skills as a developer. Tests can help you by improving your ability to write code. Recruiters are likely to hire developers who have experience with testing code. One of the reasons developers will skip testing is because it always seems so trivial. In the past, this was true. Where do you start? What tests should you write? What do you use for testing? Over the years, the front-end testing community has blossomed with tools and guides. In this section of the course, I want to guide you through the process of testing your code. We'll create a suite of automated tests to verify that our Vue application is functioning as expected. Your goal as a developer is to ship a bug-free application. Applications with bugs lead to bad user experience. A bad user experience leads to users leaving your app, never to return. Testing can help prevent this from happening. Let's take a step back for a moment. What is testing? Testing is the process of checking that an application is functioning as expected. For example, if a user clicks the login button, the authentication component should open on the page. The interactions users have with our application will change its behavior. Testing will help us verify that the correct behavior always occurs. The thing about testing is that there are different techniques. There are two main approaches to testing your applications. There's manual testing and automated testing. We're going to learn how to automate tests, but to understand the benefits of automated testing, let's look at manual testing first. From the beginning, we've been manually testing the application. After writing some code, we proceeded to test if it worked in the browser. Sometimes we even checked other parts of the app to make sure they worked. We would never write code and then claim it worked. We always tested new features in our app manually. Manually testing an app is perfect for small applications. If it takes less than 3 minutes to test, you don't need to write tests. However, as your app scales, you may find the process cumbersome. Manual testing isn't efficient. We're human. We can easily become bored if we have to perform the same tasks repetitively. As humans, when we're bored, we tend to lose focus. This can lead to bugs bleeding through into production. Manual testing doesn't scale. This is where automated testing comes to save the day. Automated testing is when a program takes care of testing your application for you. Similar to how you would do it, it'll go through a list of tasks to execute. You can test functions, components, events, and even screenshots. If all tests pass, you can go ahead with pushing the app into production. Otherwise, it'll tell you where things went wrong, thus saving you the time of having to find where the bug is present. The best part is that machines can perform tests much faster than humans can. The advantages are clear. Automated tests are the way to go. In this section, we're going to focus solely on automated testing. The word testing is a very broad term for what the testing world has to offer. If you do your own research, you'll come across dozens of definitions and tutorials for different types of testing. You may also come across libraries that perform tests differently. To make things easier, we can generally categorize tests into 3 groups: unit tests, snapshot tests, and end-to-end tests. Let's discuss each of them. The first type of test you'll become familiar with are end-to-end tests. An end-to-end test is used to check if the flow of the application is behaving as expected from start to finish. The purpose is to make sure things look like they're working from the user's perspective. Here's an example of what an end-to-end test could look like. When writing tests, you need to think of them as a series of steps. Let's say we wanted to write a test for checking if a calculator can return the sum of 2 values. Step 1. Open the browser. Step 2. Navigate to the URL where the calculator is loaded. Step 3. Press the 1 button. Step 4. Press the plus button. Step 5. Press the 1 button again. Step 6. Press the equal button. Step 7. Select the element that holds the result. Step 8. Compare the result to the number 2. Lastly, the test will tell us if it passed or failed. At first glance, it may seem like end-to-end testing is the only type of test you will ever need to write. Unfortunately, that's not the case. End-to-end testing can cause a lot of issues. Trying to automate user behavior in a browser can be time-consuming. Tests can take up to an hour if you write a lot of them. On top of that, if a test does fail, you may not know the reason why. You may know which test failed, but you don't know why it failed. You will have to retrace the steps of the test to understand why it failed. Sometimes it may not even be because of the code you've written. Your app could be working fine, but one of the APIs you're using could be down during a test. This downtime can cause a test to fail. One day a test will work, and the next day it may not. Generally, end-to-end tests are not the most reliable way to test an application. Most developers who write tests don't rely on this type of testing for their application. This leads us to the next type of testing, unit testing. Instead of testing an entire page in the browser, you can run tests against small sections in your application, hence the word unit. Unit tests are reliable because they're fast and can tell you where a problem is. Unit tests can be defined for functions and components. We're going to use the calculator example again. Unit tests are much smaller. A unit test isolates the function that calculates the sum of the values. The sum function is where an error is most likely to occur. The test would look something like this. Step 1. Pass in two values to the function. Step 2. Check if the return value is correct. If it's incorrect, throw an error. Step 3. End the test. Basically, a unit test is a way to check bits and pieces of your code in isolation. The main advantage of writing unit tests is that they're fast. After making changes to your source code, you can immediately run a test to get feedback on your changes. Another benefit is helping developers better understand the code base. Let's say you're hired to work on an existing project. The first thing you'll want to do is become familiar with the existing code base. A great way to learn about a project is by viewing the tests. Tests are made to be very descriptive and provide documentation. This is because a test is checking the behavior of a function. In a way, that can help you figure out what a function is supposed to do. You can study a test to quickly learn what functions and components do in the application. It'll help you get up to speed with things. Overall, unit testing is usually the type of testing most developers like to use. Unit testing isn't perfect though. There are two major issues you'll face when creating them. The first is that it makes it unappealing to refactor your code. If you want to restructure your application, you will also need to update your tests. Even something as simple as splitting your function into two functions can be time-consuming. Unfortunately, there isn't a way around this besides better planning and structuring your code. The second issue is testing small pieces of an application. It's like testing out the parts of a machine. The parts of a machine can work, but what if they can't work together? This can render our tests useless. There is a way to get around this, but I'll explain in a moment. Let's talk about the last type of testing, called snapshot testing. You're probably familiar with the game of Spot the Difference. It's a game where you're presented with two nearly identical images. The objective is to spot the differences. That's what snapshot testing is. It's a program that will take two snapshots of your application and compare them. If it spots any differences, it'll consider the test a failure. Snapshot testing, similar to the other types of tests, comes with a set of challenges. The biggest challenge is being able to test on different browsers and operating systems. The smallest differences can cause a test to fail. There are ways around this, which I'll discuss later in the section. We've identified the most common types of tests you'll encounter. The question is, which do you use? The answer is all of them. If you were to search for the phrase pyramid of tests, you'll come across an image similar to what I'm showing you. Tests are not something exclusive to Vue or the front end. It's a concept that's used across all software languages and platforms. The main consensus is this. A majority of your tests should be unit tests. About 60% is the recommended proportion for unit tests, 30% for snapshot tests, and lastly, 10% for end-to-end tests. Unit tests make up the majority because they're quick and straightforward. In contrast, end-to-end tests are slow and sometimes unreliable. Keep in mind that this is merely a recommendation. You may not always have a suite of tests that fit this proportion. There's one important question I want to answer before we move on. When should we test an application? The goal of testing your application is to make development faster. Bugs can impact how long it may take to build an app. If you carelessly write tests, you may end up crippling yourself by spending too much time on tests that aren't completely necessary. You don't have to test every single line of code. With experience, you'll understand what you should and shouldn't test. There is one general rule of thumb I recommend for determining when you should write a test. The rule is, if it doesn't save you time, then don't bother writing it. At the very beginning of this video, I talked about how manual testing can take a while to execute. The larger your app is, the longer it'll take to test. The purpose of writing tests is to automate the process and help you catch errors in your application. If a test doesn't help you reduce your testing process, it likely isn't worth writing. There's one last question I often hear, which is, what do we test? I've talked about how the purpose of unit testing is to test bits and pieces of code. I also mentioned how tests shouldn't focus on single lines of code. The question then becomes, what should we be testing? I recommend testing the output of components and functions. If you think about it, that's generally what most of the code we write does. Every function or component will have an input and output. We're going to be writing tests where we'll pass in data to a component. The test will check the output of the component. If it outputs the desired result, it'll pass the test. The idea of input and output is an important concept to understand for tests. Testing is about input and output. In a test, you supply an input, receive an output, and assert that the output is correct. You should write tests from the perspective of a developer who's using the component but is unaware of how the component functionality is implemented. That was a bit of an introduction. This lecture was a general overview of things. From here on out, we'll start writing tests. When you're ready, I'll see you in the next lecture. There are a couple of important concepts to discuss before writing a single line of code. There are a couple of questions I want to answer. The first question is, what are we going to be using for testing? Just like there are different frameworks for creating apps, there are various libraries for writing tests. We have quite a few options. In the Vite community, the most popular choice is Vitest. It's the official tool for projects built by Vite. Other popular choices are Mocha, Jasmine, and Jest. One of the great things about testing is that a lot of the concepts are similar between frameworks. The syntax is different. It's kind of like switching programming languages if you've ever experienced that. A lot of what you'll learn in this section can be carried over to other testing frameworks. In the resource section of this lecture, I provide links to all the testing tools I've mentioned so far. Even though Vitest is developed by the Vite developers, it'll work with any JavaScript library. It works great with Vue. Its main focus is to help us create unit tests. It doesn't do end-to-end testing. We'll be using another tool for that. The next question is, why do we need a testing tool? It's true, we can test Vue without using a library, but they're incredibly helpful. They can do a couple of things for us. Firstly, they can generate a report of tests that have passed or failed. Secondly, they can help us organize tests. Large apps can have hundreds of tests. You'll want to organize things for readability. Lastly, Vite has a set of functions for helping us write tests. For example, it can verify that two values match. We'll be exploring these functions as the course progresses. There are a couple of things to know before working with Vitest. Vitest does not run in the browser. It runs in Node. This is a problem because Vue is a client-side library. It needs a document to be able to render components. We're completely dependent on the browser document. This reason is why we never worried about the test files in our project. They were never bundled with our project to begin with. Tests are a process that runs independently. The reason why Vitest doesn't run in the browser is that loading the browser takes some time. Navigating between pages takes up more time. Running JavaScript in Node is much faster. So the question becomes, how will we test our application with Vitest? Fortunately, Vitest installs a third-party dependency called JSDOM. This dependency will create a virtual document where our components can be mounted. There are some limitations to this implementation, but we'll discuss those when we get to them. In the next lecture, we're going to start running Vitest with a UI. I'll see you there. In this lecture, we're going to install the Vitest UI package. To understand why, let's try running our first test. During the development of the master project, we installed Vitest. It's already configured and ready to go. Open the package.json file. In the scripts block, 3 commands are available for running tests. The first command is called test unit. This is the command we'll be running for most of this course. It'll launch Vitest for our application. It'll search for test files. If it finds test files, they'll be executed. Let's try running this command. Switch over to the command line. In the command line, run the following command: npm run test :unit. A test report will be generated. Naturally, the tests are going to fail. By default, the create view package will create a sample test for us. Test reports are generated in the command line. Vitest will continuously watch your test files for changes. If a test file is updated, the test report will be generated. I'm not a huge fan of viewing test reports from the command line. Fortunately, there's a package for generating a test report in the browser. This package is completely optional. However, I think it'll be easier to read reports. Let's give it a try. Turn off the test server. Next, run the following command: npm i-d at vitest/ui. The UI package will load the report in the browser. It must be installed separately. After installing the package, we must add a flag to the command. Switch over to the package file. At the end of the test unit command, add the following flag: UI. Lastly, in the command line, rerun the test unit command. After a few moments, a new tab will be opened. On the right, we are given a list of test files. We can click on a test to view more info on a specific test. We can even view the original source code. If we update a test file, the browser will reload the test. Optionally, we can force tests to run by clicking on the play button at the top left corner. In addition, we can switch between light and dark mode. In my opinion, the UI makes testing easier. Feel free to stick with the command line. In fact, you can view the command line for the same test report. Vitest will generate the test report in the browser and command line. Now that everything is ready, let's begin writing a test. In this lecture, we're going to write a test. Luckily, everything we need is already installed for us. In the command line, I'm running the Vitest server. For the rest of this section, the server should always be running. It'll be able to pick up new tests. We can write tests from the source/components/tests directory. For starters, the project will add an example test file. We can safely delete this file. We're going to start fresh. Next, create a file called example.spec.js. Spec is short for specification. It's common practice to add the spec extension to help developers identify which files are test files. After all, unit tests are written in JavaScript. We don't want to cause confusion. If you think about it, unit tests are specifications for how your code should behave. Each test specifies a result to expect when the function you are testing is called. The first test we'll be writing is what's called a sanity test. If a test fails, you will spend time trying to figure out why it isn't working. In some cases, a test may not fail because of your code. It can be because the tools we're using aren't working correctly. It's common for tools to fail. If a tool fails, we'll need a way to verify it was a tool that failed and not the test itself. A clever way to test this case is by writing a test that will always pass, or at least it should. If it doesn't, we'll know for sure our problem isn't with the codebase, it's with the tool. This is what's called a sanity test. If the sanity test doesn't pass, we know that there's a problem with the tool and not our codebase. I highly recommend writing a sanity test as your first test. We're going to write a sanity test inside the example test file. At the top of the file, import a function called test from the Vitest package. Next, call this function. The test function will allow us to write a test that should be included in the report. If you've worked with alternative test frameworks, you may not be used to importing this function. Normally, a library's functions are defined in the global namespace. For Vitest, this is not true. However, you may want the same behavior. This behavior can be achieved by updating the configuration for Vitest. Open the vite.config.js file. Vitest can be configured from the Vite file. At the top of the configuration object, add a property called test. This property is an object of configuration settings for the Vitest library. We can enable global variables by adding the globals property with a value of true. By enabling this option, most of Vitest's functions will be available in the global namespace. We won't have to import some of the functions from this package. They'll be available immediately. These changes may not take effect until the server is restarted. Back in the command line, restart the test server. Back in the example file, we can remove the import statement. We can freely call the test function without importing it. However, that doesn't resolve all issues. ESLint may throw an error. It does not recognize the test function as a global variable. We can fix this issue by registering it as a global variable. Open the ESLint configuration file. Inside the overrides array, add an object. Vitest's functions are exclusive to test files. We don't need to expose these variables to our application code. Rather than applying these changes to all files, we can apply them to test files. The overrides array can apply settings to specific files. Inside the object, we must add an array called files. The files array can contain a list of files. Let's add the following pattern: source/components/tests/***.spec.js. The pattern we're using will override the settings for files with the spec.js extension from the tests directory. After adding the files, we can add an option called globals. This option is an object of variables that can be used from within our files. ESLint will throw an error if a variable is not listed in this object. Let's add the test function. The value for this property will be read-only. The name of the function must be listed as property name. By setting the variable to read-only, developers will not be allowed to override the variable's value. We'll be limited to calling this function. While we're here, let's add more global variables with the same value. They're called describe, expect, vi, before each, and it. In future lectures, we're going to be using these functions. We might as well add them. If we go back to the test file, the errors will go away. Great! Let's get back to writing the test. The test function has two arguments. The first argument is a string that helps us identify the test in the report. Vitest will generate a report with a list of tests that have passed or failed. The value for this argument is the name that will appear in the report. The identifier should be short and concise. The name of our test will be called sanity test. The second argument is a function that'll run when we test our application. We'll pass in an arrow function. We're going to create what's called an assertion. In the software development world, an assertion is an expression that evaluates to either true or false. It's as simple as that. If the assertion we create evaluates to false, the test fails. If the assertion evaluates to true, the test passes. We're going to create an assertion that checks if the Boolean value true is equal to true. We can use a comparison operator to create this expression, but Vitest has an even better solution. Inside the function, add the following: expect true to be true. We're using another global function defined by Vitest called expect. This function will return an object with functions that can be used to test the value passed into it. In the resource section of this lecture, I provide a link to the expect function. The expect function takes in a value. It can be any type of value. It'll return an object with methods you can use to perform a test on the value you passed in. On this page, there's an extensive list of functions that can be called. One of the functions is called toBe. The toBe function can be used to compare primitive values. Let's review the test report. As you can see, the sanity test has passed. That's the goal of a sanity test. We're creating a test that will always pass to check if the tools we're using works. If the test doesn't pass, we'll know that there's a problem with the tool and not our tests. Before I end this lecture, I want to talk about one more thing. Back in the editor, we're using the test function to run a test. There's an alias for the test function called it. In some functions, you may find developers use the it function instead of the test function. We can swap this with the it function. There isn't a difference between the two functions. They do the exact same thing. The it function was introduced for those who prefer to write less code. For the remainder of this course, we're going to continue using the test function. In this lecture, we're going to write a test for the Vue application we've developed. We'll need to use a library called Vue Test Utilities. It's a library that's going to help us greatly by making it easier to interact with our Vue application. Currently, I'm looking at the About component file. It's a simple component. It's perfect for writing a test for. We're going to write a test that will check if the component is rendering the text content inside it. This is a common test you may write. You will want to check if a component is outputting the correct content. In order for this to be successful, we'll need to mount the component. Mounting is the process of inserting a component into the document. In an earlier lecture, I mentioned that Vitest doesn't run in the browser. Instead, it runs in Node. Despite Node not having a document, Jest uses a third-party package called JSDOM. JSDOM will take care of creating a virtual document that has a similar API to the document API in the browser. The test we'll write will mount the component onto the JSDOM. If the mounting is successful, we'll be able to check the text inside the component. Let's create the test file. In the tests directory, create a file called about.spec.js. It's important we add the spec.js file extension. It's how Vitest will know which files contain our tests. Other than that, we have full liberty as to how we name our files. I recommend calling your files relative to the component you're testing. We're creating a test for the About component. It makes sense to call the file about.spec.js. Inside the file, we'll call a function called describe. We're going to be writing a couple of tests. During the testing phase, we want to keep things organized. The describe function allows us to group one or more tests together. This is what's called a test suite. Every time we write a new suite of tests, we'll wrap the tests with a describe block. It takes two arguments. The first argument is a string describing the test suite we're creating. We'll pass in the following: about.view. The second argument is a callback function containing the tests. We'll pass in an arrow function. The describe function can be nested multiple times if we'd like. There isn't a limit as to how many times you can nest the describe function. It's a great way to organize your tests further. There's some debate as to whether you should nest describe functions. It's a case-by-case thing. For this course, we're going to limit ourselves to one level of describe blocks. If you want to go further, that's fine. Inside the function, we're going to call the test function. The description for the test will be the following: renders inner text. We'll pass in an arrow function for the second argument. The test we're writing will check if the component renders the inner text we have in the template. It's a rather simple test. Before we can check if the text is present, we need to mount the component. Keep in mind, Vitest runs independently from our application. The music application hasn't been initialized. As far as Vitest is concerned, the document is empty. We'll need to mount the component. Notice how I'm saying component and not instance. The purpose of a unit test is to test bits and pieces of our code in isolation. We don't want to initialize the application if we don't have to. We want to run as little code as possible. A unit test should test small portions of your code in isolation. The about component doesn't rely on external files. This is perfect. We'll be able to test the component completely isolated from the app. There is one problem. Components are not instances of Vue. They're an object that can be registered with the component function. If we want to create an instance out of the component, we'll need to create what's called a constructor function. A constructor function is what takes care of creating a new instance out of an object. When we use the createApp function, we're calling a constructor function with a new instance of Vue. Components don't ship with a constructor function, so we won't be able to mount the component. This issue can be resolved by using the Vue Test Utilities library. It provides a method for converting a component into an instance that can be mounted. At the top of the file, we'll need to import the about component. The path to the file is the following: @/views/about.vue. We can continue to use the character in our import paths. The CLI plugin will take care of creating an alias that points to the source directory. This shortcut makes testing so much easier. Next, we'll need to import a function called mount from the Vue Test Utilities module. The Test Utilities package was installed by the CLI plugin. It's bundled with methods for helping us interact with our Vue application. The function we're importing will do two things. First, it'll convert a component's options object into a constructor function. It'll then create an instance out of the constructor function it creates. Lastly, it'll mount the instance. It's a single function that conveniently takes care of everything for us. Inside the function, we're going to create a variable called wrapper. Its value will be the object returned by the mount function. The mount function requires the component we'd like to mount. We'll pass in the about component. The mount function returns what's called a wrapper. The wrapper object contains methods and properties for interacting with the component. We'll be able to do things like call methods, retrieve attributes, and even destroy the instance. It's possible to perform this task without the Test Utilities library, but it's much more elegant and quicker to use it. The component is mounted. We can begin to test it. We'll write the assertion in the next lecture. In this lecture, we're going to continue writing our test for the about component. We've taken care of mounting the component to the document. The next step is to write an assertion. We're going to call the expect function. The test we're creating will check if the inner text is outputted. Therefore, we'll need to access the inner text of the component. We can do so by calling the wrapper.text method. The wrapper object represents the component. It has a method called text that will return the inner text of a component. We'll chain the toContain function. The toContain function will check if a string contains the string you pass into it. We'll pass in about. The assertion we're making is the following. We expect the text to contain the string about. You'll notice that we're able to form statements based on the functions we're chaining. Most testing tools are verbose. It makes it easier to understand what we're testing. This is by design. It allows other developers to easily understand what you're testing. Let's try running this test. Switch over to the browser. The test will have successfully passed. Fantastic! We're able to accomplish this thanks to the View Test Utilities library. In the resource section of this lecture, I provide a link to the wrapper API we used. This library helps write expressive tests that are easy to read. It might seem confusing at first, but it'll make sense the more you use it. We'll get plenty of practice using it. There's another method I want to introduce that we can use to mount the component. Switch back to the editor. We're going to update the import statement to import a function called shallowMount instead of mount. Next, we'll replace the use of the mount function with the shallowMount function in our test. The shallowMount does the same thing as the mount function. It'll take a component, mount it, and return an object with methods and properties for interacting with the instance. The main difference is it'll limit how many children components the instance may have. Here's an example to show the differences between the two functions. The mount function will allow the component to load as many children as it wants. The shallowMount function will limit the component to one level of children components. If the child component of the component we're mounting attempts to load additional components, they will not get loaded. It's a useful method for isolating the component. It'll prevent a test from returning a false positive. This issue can occur if the children component contains the content we were checking for in the component we mounted. For the rest of this course, we're going to use the shallowMount function whenever possible. It's much faster and efficient than the mount function. There is an alternative syntax for shallow mounting a component. We can use the mount function to shallow mount a component. I'll switch this back to the mount function for a moment. The shallowMount and mount functions have a second argument for configuring how the component is mounted. We can pass in an object. We can add a property to this object called shallow with a value of true. The shallow property will do the same thing as the shallowMount component. It'll prevent children components from getting rendered. The shallow property and shallowMount functions perform the same task. There isn't a difference between the two. You can use whichever you prefer. I prefer to use the shallowMount function for readability. I'll change this back to the shallowMount function. Let's try running the test. The test will still pass. Great! Thanks to the View Test Utils library, we're able to test components and interact with them. In this lecture, we're going to write a couple more tests to practice using the wrapper API and matcher functions. We have a component called SongItem. Open it in your editor. This component relies on the parent component to pass down data. In the script block, the data that powers the component is coming from a prop called song. We're going to write a test that will check if the component is correctly rendering based on the song data. We'll need a way to pass down data from the test. Typically, it'll come from an external source. However, it's usually recommended to use mock data. We're not interested in testing the request for the data. We want to focus solely on testing if the component can render the correct output. In the tests directory, create a file called songitem.spec.js. We'll need to import the songitem component. The path to the component is @/components/songitem.view. Next, we'll import the shallowMount function from the View Test Utilities module. We'll be mounting the component. The shallowMount function will help us with mounting it. The first thing we'll do is call the describe function to group the test suite. We'll use the name of the component as the identifier. Inside the function, we'll call the test function. We're going to create a similar test to what we had before. We'll check if the component is rendering the correct inner content. Here's the catch. If we look inside the songitem component, we'll find that it isn't rendering static content. Everything is completely dynamic. It's still testable. we will need to take extra steps. The test we'll create will check if the component is rendering the name of the author. The author name is being rendered in a span tag with the classes TextGray500 and TextSM. Inside the element, we're using the expression song.displayName. Back in the test, the name of the test will be the following: renders song.displayName. We'll pass in an arrow function for the second argument. The very first thing we'll do is mount the component. We'll create a variable called wrapper. Its value will be the object returned by the shallow mount function. The shallow mount function requires the component to mount. We'll pass in the song item component. We need to pass the song data to the component. Otherwise, we won't be able to test it properly. The shallow mount and mount functions have a second argument we can use. Pass in an options object for the component. This argument will allow us to pass down data to the component. We'll define a variable for containing the data to pass down to the component. Above the function, create a variable called song. Set it to an object. The test we're creating will check if the displayName property is rendering in the component. We'll define a property called displayName. Its value will be test. There are additional properties that the song object should have, but we're limiting our test to the displayName property. We don't need to define the other properties at this time. Next, inside the object of the second argument, we'll add an object called propsData. The propsData option is where we can add in props for the component. The props object is where we can add in props for the component. The shallow mount function will take care of passing in the data as a prop. Inside the object, we'll add the song object. Great! We can write the test to check if the component is rendering the name of the author. We'll call the expect function. We'll pass in the value returned by the wrapper.text function. Lastly, we'll chain the toContain function with the song.displayName property. The test will essentially check if the displayName property is present in the component. Let's try giving things a test. We've received an error. The error is stating that we're using a component called routerLink that is undefined. The reason we're receiving this error is because the routerLink component isn't registered. Remember, we're testing the component in isolation. We don't have access to the components registered by the viewRouter component. Therefore, the routerLink component isn't defined. We'll resolve this issue in the next lecture. In this lecture, we're going to fix the error we encountered in our last test. The error is telling us that we tried using a component called routerLink. The routerLink component is a component registered globally by the router library. Our test is running in isolation. It doesn't have access to global components. This issue can be resolved by registering the routerLink component. You may be tempted to register the entire router plugin, but that's not considered good practice. We don't care about the other features of the router plugin. We just want the routerLink component it defines. Also, we don't even need the routerLink to be functional. We're not testing if the routerLink works. Our code is testing for something entirely different. We can do what's called stubbing. Stubs are fake or dummy components. They're a way to trick Vue into rendering a completely different component or element. We have the option of creating a stub. However, the Vue Test Utilities library comes with stubs already. We can use them to create a fake component. They're a great way to create a stand-in for a component that doesn't need to be completely functional. The Vue Test Utilities library comes with a predefined set of stubs for mimicking the most common components. It has a stub for the routerLink component. Let's use it. At the top of the file, we'll update the import statement for the Vue Test Utilities package. We'll add on to the import list by adding the routerLink stub component. The routerLink stub object is a fake component that mimics the behavior of the routerLink component without relying on the router library. Let's register it as a component. In the shallow mount function, we're passing in an object. We'll add a property to this object called global. The global property will allow us to register global components, plugins, and mixins. We can register a component by adding the components object. In this object, we can register a component like we normally would. The component we're trying to create is called router link. We'll add this to the object. Its value will be the router link stub component. After making those changes, the test should pass without a problem. Let's go back to the UI and rerun the tests. The tests will run smoothly. We were able to fool our application by creating a fake component. This is what's known as stubbing. Stubbing is something that you'll do frequently. Keep in mind, we're trying to test bits and pieces of our application. We don't want the whole app to be functional. That's the purpose of a unit test. Stubbing components is very common in unit tests. While the test passes, we can further improve upon the test we created. Switch back to the editor. In our test, we're calling the text function on the wrapper object for the component. This function will return the entire text content of the component. It works, but we want to be more specific with our test. We want the name of the author to render in a specific location in the component. The wrapper API comes with a function for selecting an element in the component called find. You can think of the find function as similar to the query selector function. The find function will return another wrapper object. We'll be able to call the text function on it to retrieve the inner text of the element. Let's modify our code to use the find function. Above the test, create a variable called compositionAuthor. The value for this will be the function wrapper.find. The find function has one argument, which is the CSS query to find the element. We'll pass in .textGray500. This function will return another wrapper object. The test can be updated to use the compositionAuthor object instead of the wrapper object. The compositionAuthor element we're testing should only have the name of the author inside it. We'll update the test to make an exact match instead of a partial one. We'll replace the toContain function with the toBe function. This will make an exact match comparison. Let's run the test. The test will pass without a problem. Great. We've successfully tested an element's inner content. It's correctly outputting the data we passed in. We'll keep writing tests in the upcoming lectures. In this lecture, I want to quickly talk about a type of test you should mostly avoid. There's a common pitfall some developers fall into called a Boolean assertion. A Boolean assertion is when you compare two Boolean values. If a Boolean assertion fails, the description doesn't help you, which is why they're not recommended. Let's look at an example. Open the song item test we wrote in the previous lecture. We're going to refactor the assertion to be a Boolean assertion. In the expect function, we're going to compare the text function with the song.displayName property. Then, in the toBe function, we'll change the value to false. This will cause the test to fail because we already know that the expect value will evaluate to true. That's perfectly fine. The purpose of writing this test is to show how the error that gets generated isn't helpful. Let's go back to the UI. Run the test. As expected, the test fails. The report tells us that it expected false, but received true. This report isn't helpful because we don't know what exactly failed. Was it the test function? Did the element fail to render? Or does it even have the rendered text? The report isn't descriptive at all. I'm going to undo the Boolean assertion test I created. Whenever possible, avoid creating Boolean assertions. They're not very helpful. Let's continue in the next one. In this lecture, we will write two tests that will check if the parent component can pass down data to a child component. We'll write a test to check if we're rendering the correct component and check if it's receiving the correct data. Let me explain further. Currently, I have the home component file opened. This component has two sections. The first section is mostly static. The second section is rendering a list of songs. The test we'll be writing will check if the home component is capable of rendering the list of songs. There are different things we can check for during this test. Let's explore what we can test. In the tests directory, create a file called home.spec.js. We'll need to import the shallow mount function and home component file. Next, we'll call the describe function with the identifier of home.view. Then, we'll call the test function inside the callback function of the describe function. The description for the test will be the following: renders list of songs. Inside the function, we'll need to mount the component if we want to test it. Create a variable called component. Its value will be the shallow mount function with the home component passed in. There are different things we'll be testing for. The first test we'll create will check if the component is capable of rendering the correct number of songs. In the home component, we have one data property called songs. It's an empty array by default. The songs array gets filled when we make a request for the data in the created lifecycle function. We're not going to rely on this request to add data to the array. There are a couple of reasons why you don't want to send HTTP requests in a test. The reason we're not doing so is because it can be unreliable if the request fails. A request can fail because an API is down. If that's the case, our test will fail. It's not our test's fault. In addition, requests take a while to complete. We want our tests to run as fast as possible. Lastly, we have no idea how much data will be returned. It's easier to run a test when we know how many results we can expect. We can resolve this issue by using mock data. Mock data is another way of saying dummy data. We're not going to use real data. It's common for unit tests to use mock data because it's faster. It's also necessary. We've written a few tests so far, but we've already bumped into a few problems. By isolating a component, the component may not function correctly without external data sources or third-party libraries. This is a common problem we'll encounter. There are two solutions. We can either import the necessary information or provide the component with mock data. It's better to use mock data because it keeps the component as isolated as possible. We're trying to test a component as if it can stand alone. Back in the test file, we're going to add an options object to the shallow mount function. We can change the data in a component by adding the data function to the options object. We want to change the songs array. Above the function, we'll create a variable called songs. Its value will be an array of 3 empty objects. We'll add this to the object returned in the data function. We're using empty objects because we're not interested in providing complete data to the component. We just want to check if the home component is capable of rendering the list of songs if there are items in the songs array. We don't need every object to be filled with properties to accomplish that. The component should generate 3 song item components based on the data of the home component. The next step is to select the list of songs in the component. Below the shallow mount function, create a variable called items. Its value will be the value returned by the component.findAllComponents function. The findAllComponents function is similar to the querySelectorAll function. It'll return an array of components it finds inside the component it's being called on. It's specifically for selecting components, not regular HTML elements. We want to select the list of songs, which is the song item component. This is where things can be tricky. We need to select the component, not the element it generates. Luckily, we can do that with the findAllComponents function. We don't have to pass in a CSS query. we have the option of passing in the component it should look for. At the top of the file, we'll import the song item component. This is the component that is being looped through to generate the list. We'll pass it into the Find All Components function. The Find All Components function will search for all song item components in the home component. We can begin to write the test assertion, called the expect function. We'll pass in the items array. Next, we'll chain the toHaveLength function. We'll pass in the songs.length property. The test we're creating will check if the items array is equal to the length of the songs array. In theory, the home component should have generated the same number of song item components as there are objects in the songs array. The toHaveLength function will compare the length property in the UI run the test. We'll receive an error. The $T function is undefined. We'll look at why we're getting those errors in the next lecture. In this lecture, we're going to mock a method. We'll receive an error because the $T function is undefined. Open the home component file in your editor. In the home component, we'll look at our template. In the template, we're calling the $T function to output a translation. The Vue i18n library defines this function. The library isn't registered because the component is being tested in isolation. We have two options. We can register the plugin or mock the function. We're going to mock the function because the test we're writing doesn't need the plugin to be completely available. Mocking is the process of creating a fake feature in our app. We can mock functions, components, directives, almost anything, really. We've already experienced how to mock a component by using stubs. Whenever deciding between mocking or importing the feature, you need to ask yourself if the feature is necessary for the test. If the test requires a specific feature, we'll import it. Otherwise, if it can be mocked, it should be mocked. Let's open our test file. We can mock global methods by using the global option. We'll add it to the shallow mount configuration object. Previously, we used this option to stub the router link component. We can use it to mock other global features. We can mock global functions by adding the mocks object. The mocks object allows us to define global variables and functions. It's important to understand that this is not for adding methods to a component. The functions you define in this object will act as global functions. The $T function is a global function, not a method for the component. There's a distinction between the two. We'll define the $T function. The function will have one parameter called message and return it. Basically, this function will return the original message. It'll result in outputting incorrect translations. That's perfectly fine. We're not interested in testing the translation. It's not the main focus of our test. Let's go back to the UI and run the test again. The test will pass without a problem. Great! We're not finished with our test yet. We know for sure it's rendering the list of songs. However, we don't know if it's rendering the list in the correct order. The next test we'll write will check if each song item component is rendering the correct data. We don't want the list to be in a mixed order. The first list item should have the first object, the second item should have the second object, so on and so forth. We'll create a loop to test each item. Let's go back to the editor. We're going to call the forEach function on the items array. The findAllComponents function returns an array. We can run array functions like we would any other array. In the callback function, we'll add references to the item and index in the array. We'll call them wrapper and I respectively. Let's switch to the song item component for a moment. The component will accept the data via a prop. It assigns the data to a prop called song. we'll create a test that'll compare the value of the song prop to the item it corresponds to in the array. If they both match, then the test should pass. Back in the test, inside the loop, we'll call the expect function. The value we'll pass in is wrapper.props.song. The props function will return a component's props. We can then access any of the props through their name. In this case, we're accessing the song prop in the component. We'll want to compare this value to its corresponding item in the array. They should both match since the home component will loop through them in the order they're passed in. Chain the to function. We'll pass in songs I. Let's run the test. The test will pass. By using the props function, we were able to retrieve the data in a child component to compare it with data from the parent component. There's one last thing I want to mention before ending this lecture. The test will work without a problem. In our test, we need the song item component to be functional. However, the last time we wrote a test for the song item component, we had to mock the router link component. We don't need to in this case. The reason we're not mocking the router link component is because we're using the shallow mount function. If our child components are using other components, they will not work, nor will the test throw an error. The shallow mount function limits what children components can do. Therefore, we don't need to mock the router link component. This is why we're not receiving an error. We'll leave it at that. In the next lecture, we'll write more tests. In this lecture, we're going to test attributes. The next test we'll write will check if a component can render a dynamic attribute. Most of our tests have been checking the inner content of elements. But what about attributes? Testing attribute should only be performed if the attribute is dynamic. You shouldn't be testing attributes that are static. We don't have many attributes in the application that are dynamic. We'll create one as an example. Open the song item component file. We're going to assign a dynamic ID attribute to the list item element. We'll use the ID of the document to help us generate the ID. On the list item element, bind the ID attribute. Set it to the following: song ID song.docID. We're going to write the test in the songitem.spec.js file. We have a test that takes care of mounting the component. We can copy this code to test the attribute. Let's make a copy of the test function. We'll change the description to the following: renders song.docID in ID attribute. The question I get asked often is, why are we mounting the same component twice? It's a fair question. In truth, we can move the wrapper variable up one level to the describe function. This adjustment will allow every test to use the same component. Here's the problem. Every test will rely on one instance of a component. This makes things difficult to refactor if we ever need to. If one test makes a change to the component, this can affect other tests. It's recommended every test have its own instance of a component. Therefore, we may mount the same component multiple times. This can slow tests down, but generally, it's considered worth it for more accurate test results. I'm going to undo this change. In the second test function, we'll make a couple of changes to it. First, we'll update the song object that's used as the prop. We'll change the display name property to the docID property. Its value will be ABC. Lastly, we'll completely replace the test assertion. We'll call the expect function. The test we're writing will check if the ID attribute is being set. We'll need to provide the expect function with the ID in the component. We can access the attributes by calling the attributes function on the wrapper object. The attributes function returns an object of attributes in the component. We can access any of the attributes in the object by their name. We'll access the ID attribute. Next, we'll chain the toBe function. The value to pass in will be song ID song.docID. We're finished. Let's run the tests. The tests will run without a problem. There are a few things I want to point out before we move on. Let's go back to the editor. First, the attributes function we're using will retrieve the attributes on the root element of the selection. It will not retrieve attributes that are in children elements. In the test, the wrapper will represent the component. It'll retrieve the attributes on the root element of the element. In this example, it would be the list item element. If we were to move the ID attribute to the composition element, this would cause the test to fail. I'll run the test again. The test fails as expected. This is important to understand. If your test for attributes fails, then you'll want to make sure you're selecting the correct element to begin with. I'm going to undo the change I made. Another thing I want to point out is how to handle the class attribute. Vue's testing library comes with a function for retrieving values from the class attribute. Let's refactor the test to check for a dynamic class. In the template, we'll need to update the attribute in the component. We'll change the attribute from ID to class. Next, we'll add another class attribute, except this time it'll be static. Its value will be example. Vue will merge the classes together. This merge will make things a bit more difficult because the class attribute can have multiple values at any given moment. Luckily, the libraries we're using accounted for this. Back in the test file, we're going to comment out the test assertion we've written. We're leaving it in for example purposes. We'll call the expect function again. This time we'll pass it in the wrapper.classes function. The classes function will return an array of classes. The class attribute is still accessible via the object returned by the attributes function. The main difference is that the attributes function will return the attributes values as a string. The classes function will take the time to convert the classes into an array. This can make it easier to test. We'll chain the toContain function with the same value we passed in the previous test. The toContain function can search both strings and arrays. If the array contains the class we're passing in, it'll pass the test. Let's try rerunning the test. The test will pass. Fantastic. That's how you would test attributes in a component. When writing tests for attributes, make sure it's for dynamic attributes only. If an attribute is static, there isn't a point in testing it. It's time to start testing the state of our application. In our application, we're using Pinia to help us with managing state. As far as testing is concerned, you will most likely write tests for verifying the behavior of your actions and getters. For starters, we're going to write tests for our actions. Let's write a test for verifying that the user gets authenticated into our application. Open the user.js file. In this file, we have an action function called authenticate. If this function gets called with valid credentials, the user should get logged into our app. At the end of the function, the user logged in property will be set to true. We can assert the value of this state property. Let's get started. In the tests folder, create a file called pinia.spec.js. Next, import two functions called setActivePinia and createPinia from the Pinia package. We aren't going to import any components because we want to test the store in isolation. We don't need to mount a component to test the store. We will need the createPinia function to create a fresh instance of the Pinia class. Next, we'll import the user store. Add the describe function with the following identifier, stores. Next, call the beforeEach function. During the testing of our components, we created a unique instance of a component before writing test assertions. This same idea should apply to testing our stores. Stores should not leak from test to test. To avoid leaks, we can reset the PINIA instance. The beforeEach function will run a function before a test is executed. Let's pass in an arrow function. Inside this function, call the setActivePINIA function. Before we can create stores, an active instance must be available. However, we can't create an active instance unless a view instance is available. The developers of PINIA have created this function for tricking PINIA of an active instance during testing. In this function, we can pass in a PINIA instance. Let's pass in the createPINIA function. Great! We'll always have a unique instance of PINIA before each test. Let's write our test. Inside the block, call the test function. The description will be the following: authenticates user. In our test, we're going to create a variable called store. We'll set this variable to the value returned by the useUserStore function. To get started, we're accessing the store. We can use the store's functions and properties like we would in our components. We can begin writing the test assertion. We're going to write two of them. The first assertion will check the default state. The second will check the state after the action has been called. Call the expect function with the store.userLoggedIn state property. Next, chain the toBe function with a value of false. This assertion will test if the state property is false. This is one way of testing a false value. Here's a cool trick you can do with tests. Vitest has a feature called modifiers. You can think of Vitest modifiers as similar to directive modifiers in Vue. They change the behavior of a function. Before chaining the toBe function, add a modifier called not. The not modifier will reverse the behavior of the function chained after it. In this example, it'll test if the state property is not false. This test will throw an error because the default value is false. Let's change the value to true. The next step is to run the action. Call the store.authenticate function with an empty object. We're passing on an empty object. We're not interested in passing in valid credentials to Firebase. Firebase is not what we're testing. We're testing if the action function sets the userLoggedIn state property to true. The authenticate function is asynchronous. If your action functions are asynchronous, you should add the async await keywords. Let's add them in the appropriate locations. Lastly, we can test if the property was set to true. We'll copy the last assertion we had without the not modifier. Alright, let's run the test. The test will fail. According to the report, Firebase requires an email. Here's the thing. We're not interested in letting Firebase run. We're just interested in our action function. To get around this dilemma, we need to mock Firebase. We'll talk about that in the next lecture. One of the main takeaways with testing the store is not having to mount a component. Stores are objects we can test in isolation. We don't need a component or Vue application to be running to test the store. That's great. It allows us to test the state in isolation. In the next lecture, we'll continue testing the store. In this lecture, we're going to mock a promise by Firebase. Before we do, I want to explain why. It's common practice to mock dependencies that send requests. Firebase is an example of this type of dependency. The reason is simple. It's possible for a request to fail due to downtime. If Firebase is down, the test will fail. Sending requests to third-party APIs can be unreliable. Rather than roll the dice, we should mock Firebase. If we mock Firebase, we never have to worry about a test failing. Vitest provides a function for helping us mock dependencies. Open the pinia.spec.js file. Below the import statements, call the vi.mock function. The vi.mock function allows us to mock a dependency. We'll discuss how it works in a moment. First, let's fill in the blanks. This function has two arguments. The first is the path to dependency. Set the dependency to @/includes/Firebase. The second argument will be a function that returns an object. Let me break down what will happen. When Firebase gets imported, Vitest will detect that Firebase is being imported from the user store. Before the file is imported, Vitest will prevent the file from being imported. Instead, the import statement will be replaced with the value from the second argument. The first argument to the vi.mock function is the import path it should watch out for. The path must match the path we're using in the user store. If these paths match, Vitest will not allow the import statement in the user store to work. Instead, it'll tell the component to import the value we're returning in the second argument of the vi.mock function. If we look at our vi.mock function, we're returning an empty object. This object is what will be imported from the dependency. This is how mocking a dependency works. We can trick our application into importing a fake dependency instead of the real dependency. We're using a fake dependency because we don't need Firebase for our test. We're not finished yet. Let's view the user store file. Scroll to the authentication function. In this function, we're accessing the auth.signin function. These properties do not exist within our mocked dependency. Therefore, the test will fail because of an undefined error. The inner contents of the dependency must be mocked too. Luckily, this process is very easy. We're going to modify the object we're returning in our function. We're going to mock the auth.signin with email and password function. Add in the auth object. Inside the object, add the sign-in with email and password function. We can't leave it at this. The function we're mocking returns a promise. This promise should be resolved. Inside this function, we'll return the promise.resolve function. This is an important step. In some cases, you can just mock a value or function and be done with it. However, when mocking a promise, the promise must be resolved or rejected. Otherwise, the test may not be able to continue. Let's try running the test one more time. Everything passes. We learned how to test an action. It does involve mocking a module, but it's well worth it. Anytime you're dealing with asynchronous tasks, you'll want to consider mocking them, especially if they're HTTP requests. They're prone to errors. In the next lecture, we'll continue writing tests for our store. In this lecture, we're going to learn how to test the components defined by the View Router library. One of the most common features we use from the router library is generating links. We should check if the router link component is correctly rendering the right links. Open the song item component file in your editor. This is a component that'll generate a link to an individual song. The link is generated with the router link component. We're binding the to property to pass in a configuration object for the link. We're telling it to generate the link based on the song route record. The record has one parameter called ID. This component will output a link. We're going to write a test that will check if the router link component can output the correct link. We'll need to provide the component the document ID because the router link will generate the link based on the ID in the route. Let's get started. We'll create a test file for testing the router. We could add the test to the song item test file. However, we're not trying to test the component specifically. We're trying to test if the router works. It makes sense to put tests for the router in a separate file. In the tests folder, create a file called router.spec.js. At the top of the file, we're going to need a couple of things. First, we'll need the shallow mount and router link stub properties from the view test utils package. Secondly, we'll import the song item component. We have everything we'll need for this test. We'll add the describe block. The identifier will be called router. Inside the describe block, add a test block. The description will be the following: renders router link. Next, we'll need to mount the component. Before we can do so, we'll need to create some data. The song item component relies on the parent component to supply it with data from the parent component. Let's create the data we'll supply the song item component. Create a variable called song. This variable will be an object of props we'll pass down to the component. The data used in the song item component is passed down from the parent component. Since we're isolating the component, we'll need to pass down the props data ourselves. The song object will contain the props data. There's one prop we'll add to the object. It'll be the document ID. Set it to a random string. Afterward, we'll create a variable called wrapper. Set it to the shallow mount function with the song item component passed in. In the second argument of the function, we'll pass in the options object. We can add the props to the component by defining the props data property. This property will be an object of props to pass down to the component. We'll pass in the song variable. Next, we'll need to mock the router link component. This may be confusing because we're trying to test it. However, we still need to mock it since we're not registering the router plugin. Luckily, the stub component from the utilities library is able to replicate the features of the router link component. It's completely testable. We can register a component by adding the global object. Then, we'll add the components object. Inside this object, we'll add the router link component. It'll be set to the router link stub component. The last thing we'll do is write the test assertion. Call the expect function. The value to expect will be the value we passed into the to property of the router link component. We can retrieve the value by selecting it. We'll use the wrapper.find component function to select the component. Previously, we used the find all components function to select components in a wrapper. The find component function will select a single component in the wrapper. It will not return an array of components, even if there are multiple copies of the same component in the template. We're not looking to test every link since they'll all point to the same song. Selecting a single component will work for our test. The component can be selected with the router link stub component because that's what we're stubbing it with. The to property is passed down to the router link component as a prop. We can access the list of props on a child component by chaining the props function. We'll access the to prop. By retrieving the prop, we can test if it's being set properly. We'll chain the to equal function. Switch back to the song item component. Search for any of the router link components in the template. We're going to copy the object we bound to the to property on the component. Then, back in the test, we'll pass this into the to equal function. Format it if you need to. The assertion we're writing will retrieve the to property value we passed into the component. We're checking if the component is being provided the correct object. Let's run the test. The tests will run successfully. We were able to test the component by checking if it received the data for rendering the link. The router library is easy to test. You will want to write tests for checking if the router is able to generate links to the pages you want to redirect users to. We are finished with unit testing. In the next set of lectures, we're going to start looking at different types of testing. When you're ready, I'll see you in the next one. In this lecture, we're going to learn about snapshot testing. From the very beginning, I mentioned 3 types of tests: unit testing, snapshot testing, and end-to-end testing. Up until now, we've been focused on unit testing. We're finished with unit testing for this section. It's time to move on to the second category of testing, which is snapshot testing. The question is, what is snapshot testing? Snapshot testing is when 2 images of an application are compared. It's similar to the game Spot the Difference. The comparison is performed by a machine instead of a human. It's much faster and accurate. We're going to be using Vitest to write snapshot tests. It's primarily a unit testing library, but can handle all our snapshot testing needs as well. There's one problem with snapshot tests. They can be unreliable sometimes because images may come out differently each time. If we're using different browsers or window sizes between each test, Vitest will produce an error. If an image is off by 1 pixel, this can cause our tests to fail even if we didn't change anything in our tests or application. Vitest solves this issue by serializing the application. A serialized value is a string that initially wasn't a string. This means Vitest will compare 2 strings instead of 2 images. This process provides for a more consistent, reliable, and faster testing result. Vitest performs serialization on the DOM. It'll take care of saving the snapshot for you. Let's review the steps taken by Vitest for performing snapshot testing. Firstly, Vitest will search for an existing snapshot. If it's the first time the test is running, it'll generate a snapshot. The snapshot will be saved. Lastly, the test will pass as long as it's able to save the snapshot. Vitest takes care of saving the file for you. We'll look at how that's done when we begin writing the test. If a snapshot exists, it'll generate a new snapshot. The latest snapshot will be compared to the last generated snapshot. If the 2 snapshots don't match, the test will fail. If they match, then the test will pass. This is a high-level overview of how snapshots work. There are 2 important points I want to make about snapshot tests. The first point is that snapshot tests should always pass if you haven't made any changes to your application or test. You will need to run snapshot tests at least 2 times before considering them a success. The second point I want to make is not to write so many snapshot tests. They're highly susceptible to failure. If you change a single class, element, component, or text, then your snapshot test will fail. If the change you made were intentional, then you'll need to update your snapshot tests. The more snapshot tests you have, the more fixes you'll have to make. Generally, I like to write a snapshot test for every component. Sometimes I may need to write multiple snapshot tests for a single component. I try my best to keep it under 3. Usually, 1 snapshot test per component is all you'll need. Let's begin writing a snapshot test. Snapshots are easy to write. We'll create a snapshot test for the song item component. It's the perfect candidate for a test. It's easy to isolate, and we can test if dynamic data is rendered properly inside the component. In the tests directory, create a file called snapshot.spec.js. We'll need to import the shallow mount function and song item component. Create a describe block with the following identifier: snapshots song item.view. Inside the block, add a test block with the following description: renders correctly. The first thing we'll do is create the prop data. The song item component expects the parent component to supply it with the data. In previous tests, we would provide the song item component with bits and pieces. This is because we were interested in only testing specific parts of the component. Things will be different with a snapshot test. The goal of any test is to test against the output. With snapshot tests, we'll specifically want to test the output of an entire component. The output of a component is the template. We'll want to make sure the template has everything it needs to be able to render correctly. In this case, we'll want to supply the song item component with a full object. Create a variable called song. It'll be set to an object. There are 4 properties the component needs in order to render correctly. They're the document ID, modified name, display name, and comment count properties. You can assign them any value you'd like. Next, let's mount the component. Create a variable, set it to the shallow mount function with the song item component passed in. For the second argument, we'll pass in an object. We can add the component's prop data by adding the props data object. We'll pass in the song variable. We're almost done preparing the component. The song item component uses the router link component to create links. We'll need to stub this component. We'll update the import statement for the Vue Test Utilities module to include the router link stub component. Back in the shallow mount options, we'll add the global object. Inside the object, we'll add the components object. Lastly, we'll set the router link component to the router link stub component. This property will replace the router link component with a dummy output. Let's write the assertion. We'll call the expect function. Pass in the wrapper.element property. The element is the root DOM element in the component. Snapshot tests require the element as the input. After providing the input, we'll chain the toMatchSnapshot function. The toMatchSnapshot function does a couple of things. It'll generate a snapshot using the input we've provided in the expect function. Afterward, it'll compare the snapshot it's generated with an existing snapshot. If a previous snapshot doesn't exist, it'll create a file with the snapshot it generated. The file will be saved in a special directory. If a snapshot does exist, it'll compare the generated snapshot with the previous snapshot. The test will pass if the snapshots match. Let's run the tests. In the Vue UI, run the task. The tests will pass successfully. The report will tell us that a snapshot was written. Let's go back to the editor to find where the snapshot was written. Snapshots are created under a directory called snapshots. You can find it in the tests directory. Inside this directory are snapshot files. Every snapshot file is saved with the snap extension. Let's open the snapshot file that was created. Syntax highlighting is not available because Visual Studio Code does not support snap files by default. We can enable syntax highlighting by installing the official Jest extension. Under the Extensions tab, search for an extension called Jest. Click Install. Initially, this extension might seem strange. However, Vitest's snapshot testing feature was inspired by Jest's snapshot testing feature. Unfortunately, there isn't an extension for highlighting syntax in a snapshot file produced by Vitest. For this reason, we must install the Jest extension. The extension will be enabled globally. It should work out of the box with our project. It'll add a lot of features for helping us with testing. We're installing it to enable syntax highlighting. Switch back to the snapshot file. You should be able to read the file more easily with the extension installed. Vitest has converted the root element into a string. If you were to look through the string, you should see the component was compiled without a problem. Every expression was interpolated with the corresponding property. This was our first time running the test. The test will pass automatically if the file was generated successfully. As I mentioned earlier, snapshot tests should pass if there weren't any changes to the tests or application. Let's run the test again to see if it passes. It indeed does. The report is slightly different this time. Vitest will not rewrite the snapshot file because there weren't any differences. It'll simply pass the test. This is great if you didn't change anything. However, in some cases, you will eventually need to change something. When that happens, the snapshot test will fail. Let's look at an example. Open the Song Item component in the editor. We're going to update the class attribute on the root element. We'll add the class snapshot. This is a fake class. It doesn't do anything. Its purpose is to showcase what happens when a snapshot fails. Back in the UI, rerun the test. The test will fail. Unfortunately, the test from the browser isn't helpful. If we're interested in viewing the differences, we must check out the command line. A report will tell us where things don't match. This result is what's called a diff. A diff is a comparison between the previous snapshot and the latest snapshot. It'll help you locate where there's a difference. It's telling us that the class attributes don't match. Let's say that we want the snapshot class to exist in the Song Item component. This is an intentional change. In this case, we'll need to update the snapshots. There's a command that'll update every snapshot test. It's not written for us. We'll need to run it ourselves. Luckily, there's an option for doing so. Press the U key on your keyboard. Vitest will listen for keyboard presses on the command line. If we press the U key, all snapshot files will be updated. After updating the snapshots, Vitest will run our tests again. The report will tell us that the snapshot was updated before it was tested. The test passed without a problem. That's all there is to snapshots. The purpose of a snapshot is to check if a component is rendering fully. Unlike unit tests, where you need to write multiple test blocks for a single component, most components will only need a single snapshot test. In this lecture, we're going to learn about the last type of testing called end-to-end testing. It's one of the more challenging types of tests to write. A lot can go wrong with end-to-end testing. We'll be talking about why you'll want to write end-to-end tests, the problems that come with it, and we'll explore the solution we'll be going with in this lecture. First things first, what is end-to-end testing? End-to-end testing is a way to check if an application is behaving correctly by automating a browser to mimic user behavior. It's basically what we've been doing already whenever we write a new feature. After writing some code, we would manually visit the application in the browser, perform some tasks, and verify the app responded with the desired results. This process is what's called manual testing. An end-to-end test does the same thing, except we can write a program to do the things we would usually do. We can tell the program to click links, fill out forms, scroll around, etc. We can completely automate the testing process. In theory, it seems like end-to-end tests can be the best approach to testing. There are a couple of problems with end-to-end testing. There's a reason why it should only make up about 10% of your tests. The first reason is that they're very slow. A couple of things need to happen before the test is complete. The program needs to turn on a server, compile your project, open the browser, navigate to the app, perform your tests, capture actions, and generate a report. It's a series of steps that need to be taken for effectively verifying the test's pass. You'll see how slow a test can run when we run our first test. The second reason is that they can be unreliable. An end-to-end test runs the application as if it were fully functional. This means that any APIs we're using will need to work. If a request takes too long, this can cause the test to fail. The last reason is it's difficult to debug. If an error occurs, you'll need to take the time to figure out why. This process can be challenging because, unlike unit tests, we're loading the entire application. The problem can be with any component. It can be with any third-party module we installed. It's challenging to track where the root cause of an error occurred. This doesn't mean that you should never write end-to-end tests. In fact, they're the most useful kind of tests you can write because you will be able to actually see how the app behaves. This perspective is something that unit or snapshot testing can't provide you. Both types of tests are great for testing individual parts, but at the end of the day, you will need to see if everything works together in unison. Two components may work separately, but do they work together? End-to-end testing can help answer that. Another disadvantage of unit testing and snapshot testing is that they can't help you test navigating between pages. You can't test how layouts will react whenever the state or route changes. End-to-end testing doesn't have these limitations. There's one last question before we look at some code. What should we be testing? You should have as few end-to-end tests as possible. You will want to test the main actions that will be performed on your app. For example, authentication is a typical action that may perform. If you're building an e-commerce shop, you may want to write a test for checking out. You don't want to test small actions like navigating from one page to the next. There are various tools available for performing end-to-end tests. The two most popular tools are Nightwatch and Cypress. For this course, we'll be using Cypress. I find it to be the easiest to use out of the two. It's much faster and well documented. The community is smaller than Nightwatch, but that's starting to change. More and more developers are switching to Cypress. On the menu, there's a page called Pricing. Click on it. First and foremost, Cypress is entirely free and open source. There aren't any limitations to using Cypress. The development team behind Cypress has developed an additional service called Cypress Dashboard. Their service allows you to run tests on their servers instead of on your own machine. It can even run tests in parallelization, which is running multiple tests at the same time. This feature will produce faster results. It does cost money. Still, it is an excellent service if you're working on a team. You don't have to use this service. Cypress can run on your machine with minimal setup. We'll be running Cypress on our machines. Fortunately, Cypress has been configured with our projects. We can start using it right away. In your editor, open a file called Cypress. It can be found in the root directory of the project. The Cypress file is a configuration file that Cypress will search for whenever you run it. By default, Vue has configured this file by adding two options called spec pattern and base URL. The spec pattern option will contain a pattern for finding test files. As you can see, any test file created in the Cypress/e2e directory will be executed. As for the second option, Cypress will launch our app in the browser. It'll need the URL for viewing our app. Once again, the URL has been configured for us. Let's check out the files in the Cypress/e2e directory. There are three additional directories called e2e, fixtures, and support. The e2e directory will contain our tests. We'll explore these files in a moment. The fixtures directory can contain dummy data. In some cases, we may need to fill out forms with dummy data. We can store data from within this file. Lastly, the support directory can contain additional commands to run in Cypress. For example, we can outsource actions such as authenticating a user into an app. Our focus is going to be on e2e directory. In the next lecture, let's begin writing our first test. In this lecture, we're going to write our very first end-to-end test. We're going to write two of them. The API for writing a test will be familiar to you. From the very beginning, I mentioned that you'd be able to switch to any testing tool. This is because most testing tools adopt similar features and syntax. Let's explore a test by writing one. The very first test we'll write will be a sanity test. A sanity test is a test that should always pass. The purpose of a sanity test is to check if the tools are correctly configured. If the test fails, we'll know that there's something wrong with our tools and not our tests. In your editor, open the cypress/e2e/example.cy.js file. This file is an example test file the CLI plugin has generated for us. Immediately, you will notice some similarities to Vitest. In the file, the describe function is being called to group a test suite. There are two arguments, the identifier and an arrow function. Inside it, The it function is called to create a test block. There are two arguments, the description and function. Other than that, everything else will be new to you. At the top of the file, there's a comment with a link to the Cypress API functions. Feel free to check it out after you're finished with this lecture. The first thing we'll do is empty the test block. We want to start fresh. The identifier for the describe block will be sanity test. We'll leave the description alone for the test block. The test we'll write will be similar to what the original test was. There are two things we'll do in the test. First, we'll visit the home page of the application. Secondly, we'll verify if the home page is rendering by checking if it contains some text. Cypress will launch a browser. We can interact with the browser by using a set of global functions defined by Cypress. The functions can be accessed with the Cy object. The first step was to visit the home page. We'll call the visit function. This function will tell the tool to visit a page. We can pass in the URL to the function. The best part about this is that the CLI plugin has configured Cypress to allow relative URLs to the application. We don't have to pass in a full URL. We'll pass in a / character. This takes care of the first step. The second step is to check if the home page contains a subset of text. We can use the cy.contains function to tell Cypress to search for some text on the page. We'll call it after visiting the page. It has two arguments. The first argument is a selector. We can tell the contains function to search for text in a specific element on the page. We're going to select the logo from the home page. Pass in the following selector, #header a:1st child. The second argument is the inner text of the element. Let's pass in the word music. We're ready to run the test. In the command line, run the following command, npm run test :e. This is the command defined by the Vue team for launching Cypress. This process may take a while for some of you. Cypress is attempting to build your project before it launches. After building your project, it'll start the server. Then, it'll open what's called the Cypress Test Runner. This program is where you can view the tests registered for your application. To run a single test, you need to click on it in the list. Let's click on the example.js file. After clicking on it, Cypress will launch a browser. Your test will begin to run automatically. We'll let it run. This will take a while. Let's review what was generated. At the top, a bar will output information about the test and additional tools for interacting with the test. It'll tell us how many tests pass and how long it took. Immediately, you'll notice the test took quite a while to complete. Keep in mind, the duration of the test is not an indicator of how long the app takes to load. Cypress is performing additional tasks during the test. This is one of the downsides of using E2E testing. They take a while to run even for a simple test like this. To the left, we have a log of what the tester did. A green checkmark will appear next to the test name to let us know everything worked. In the log, we have the option of inspecting each phase of the test. If I were to hover my mouse over any of the logs, the page on the right would update. Cypress allows you to time travel between each point in the test. This feature can help you better understand what's going on. As you can see, Cypress is extremely powerful. It gives you all the information you'll need to debug a test. The sanity test has passed. We can confirm that Cypress is properly installed. We can begin to test our application. We're going to write another test to get some more practice with Cypress. The test we'll write will check if the audio player can play music. Here's a rundown of what we'll be doing. First, we'll visit the home page. After visiting the home page, we'll select the first song in the list of songs. Then, we'll start playing the audio. The test will wait 5 seconds to let the audio play. Once 5 seconds have passed, we'll pause the audio. It's a really simple test, but it is something you would write. You will want to check if the audio player is fully functional. In the editor, create a file called audio.cy.js. All test files must have the cy.js extension. Otherwise, the test may not be picked up by the Cypress test runner. We'll add a describe block to group the test suite. The identifier will be audio player. Next, we'll call the it function to create a test. We'll use the following as a description: plays audio. In the function, the first thing we'll need to do is visit the home page. We already know how to do that. We can call the cy.visit function with a / passed in. We don't have to pass the full URL because Cypress is configured to visit our app. This allows us to pass in relative URLs. The next thing we'll do is click on the first song in the list of songs. We can select an element on a page by using the cy.get function. This function has one argument, which is the selector. We should select the songs on the home page. However, they don't have a unique selector for us to use. Let's open the song item component. Inside the first router link component, we're going to add a class called composition name. This class will help us select the links generated by the router link component. Back in the test file, we'll add this selector to the get function. This selector will work, but there is one problem. We have multiple songs in the list. We want to select the first one. If the get function finds multiple elements, it'll return an array of selections. We can select the first item in the list by using the first pseudo-selector. Afterward, we'll chain a function called click. The click function will tell the browser to click on the element we selected. The browser will navigate to the page. After the page was loaded, we'll want to play the audio. The audio can be played by pressing the play button on the page. We'll select it like we selected the song in the list. Call the cy.get function. The selector will be #playbutton. This element doesn't exist in our application. Let's add it to the button for playing a song. Open the song component file. Search for the button element. We'll add an ID attribute with the value play button. Switch back to the test file. We'll chain the click function again. This is how we'll select it on the page. This action will cause the audio to start playing. We'll want to wait a while before we pause the audio. Cypress comes with a function for waiting. We'll call the cy.wait function. Cypress will wait before proceeding with the next action. We need to pass in the time to wait in milliseconds. We'll wait for 5,000 milliseconds. ESLint may be configured to disallow waiting from within a Cypress test. If that's the case, we can disable ESLint for this line of code by pressing the Quick Fix option. The last thing we'll do is click the pause button on the audio player. We'll call the cy.get function one last time. The selector will be #player_play_button. Once again, this selector doesn't exist. We'll need to add it in. Open the player component file. On the first button, we'll add the ID attribute with the value player_play_button. Switch back to the test file. We'll chain the click function to pause the audio. We're finished. Writing tests is this simple. We don't have to worry about checking if the page has loaded. Cypress is smart enough to start clicking after the document is fully loaded. The only time we have to tell it to wait is after the audio starts playing. Before we run our tests, there's one gotcha with the test runner. The test runner will launch the preview server, not the dev server. We must build our project again before running the tests. In the command line, turn Cypress off. Next, build the project. Lastly, let's launch Cypress with the npm run test :e2e command. In the test runner, click on the audio test. Great! We've written our first real test. We were able to test the audio by selecting elements and then mimicking the user behavior of clicking on them. Cypress provides us with the functions necessary for interacting with the browser. With that finished, that wraps up this section on testing. Admittedly, testing can feel repetitive and boring, but after you've written them, you never have to worry about manually testing your app again. Testing allows you to automate a lot of the process for testing a feature. If you ever write new features for your app, you can run the tests to make sure nothing else breaks.